welcome to the last video in the series. The last thing we learned is at the very end of chemistry in both classes, both to the current seniors and new juniors, or whatever you want to call yourselves. We learned this at the very, very end of the year in both classes. So, molarity, okay, has to do with solutions, okay? And solutions are when you dissolve something in water. So let's say we're taking calcium, that guy. Let's say you're taking calcium chloride, okay, and you're dissolving it in water, okay? When you do that, okay, a compound that dissolves in water separates into its ions, or an ionic compound that dissolves in water separates into this ion. So when you'll do this, you'll have the calcium ion, which is +2, and dissolved in water, and then the chlorine ion, which is -1, dissolved in water, AQ. And again, since there's 2 in this formula, for every 1 calcium ion, there'll be 2 chlorine ions. So that's what happens when you dissolve things in water. And we're going to talk a lot more about this in terms of like why it occurs, why it's energetically favorable. We've got a lot to talk about in terms of this. So the simple process of dissolving something in water. There's a formula, okay, that is used to determine how much of the substance you're dissolving in water. And if you remember, the formula is called molarity, and the symbol is given big M. And the formula is moles of solute. Remember, the solute is the thing that gets to dissolve. So in this case, this is the solute, divided by liters of solution. Okay. It is important that it's liters of solution, because many, many times, you have no idea how many times I had to do this conversion during the 2-week conference. They'll give you the volume of the solution here in milliliters. And you got to convert to liters. Okay, so just a brief sort of segue from that. The question is, what happens when something dissolves in water? So instead of looking at calcium chloride here, we're looking at sodium chloride or table salt. And you'll see this area here we have no water. And here the ions are locked together, which is called a crystal lattice, which we'll talk about when we get to ionic bonding at the end of the year. We're actually doing bonding at the very end of the year. And depending upon the strength of this crystal lattice, okay, if it's really strong, water won't be able to do this and the compound won't dissolve, okay? But depending upon the strength, what water does is it pulls apart the ions, okay? Like here, what's happening is the salt is dissolving, and you'll see that the positive sodium is attracted to the negative oxygen in water, and that the negative chlorine is attached to the positive hydrogen. And on the final exam, you had to draw a ionic compound. I think it was rubidium fluoride or something like that. And you had to dissolve that, show how the water molecules would interact with rubidium fluoride when it dissolved. Again, what water is really doing is pulling apart or breaking apart this lattice, okay? And separating the ions. And again, the positive oxygen is going to pull, positive oxygen. The negative oxygen in water is going to be attracted to the positive ion, in this case sodium, and the negative chlorine, is going to be attracted to the positive hydrogen in water. Alright, so let's get on to using the molarity equation. So in molarity, I'm going to write the formula. There are two types of questions that you could get. Because three types of questions. Because there's 3 things in the equation. So you could solve for M, you could solve for moles, which then they'll ask you to convert to grams, usually. And then, or you could solve for the total volume of the solution. And again, you don't know how many times I did this formula during the AP conference. So let's look at the equation. Determine the molarity of 200 grams of lithium fluoride dissolved in 100 milliliters of water. So we're determining M. The first thing we got to do is convert this to moles. So again, we're going to take the 20 grams and divide by the molar mass of lithium fluoride. This you did in the previous section. Lithium fluoride, periodic table. Where did you go? So lithium is 6.94, and fluorine, which is 19. God, they made it easy. All right. And this is 25.94. So I'm going to do the division. 20.0 divided by 25.94 is 0.77 1.77100023. So I'm going to put that in for moles. So 0.77100023. And with sig figs, you don't round until the end. So you include all the numbers until the end. Okay. Now, we got to do liters. They gave us milliliters. Converting, you got to memorize this. It's got to be like this when you do this. You're going to have to do this conversion so many times. Converting milliliters to liters, move the decimal place 3 places to the left. So 0.1. Alright, and then this is division. So divided by 0.1 is 7.7101. Now we got, and it goes on forever. Now we got to worry about the sig figs. If we look at the numbers that they gave us in the problem, this has 3, this has 4. So our answer needs to have 3 sig figs. So 7.71 big M is our answer for the molarity there. Okay. Now, if you're in doubt with the sig figs, like if you don't know how many sig figs to put, you should put 3. So if you're unsure about the sig figs, okay, for whatever reason, and you're in doubt, you should put 3 sig figs. Alright, so now, do another type of problem. We got our formula. Molarity is moles over liters. So in this case, they're giving us the molarity. So we put that in for M. Okay, and they're giving us the gram amount. And we got to solve for liters on the bottom. So again, we have to take this and convert it to moles. And I guess it's the same compound. It's lithium fluoride. So I'm going to get the molar mass of lithium fluoride, which I calculated here, which is 25.94. Right here we got that molar mass. I'll go back to the problem. Alright, so 29.94. I'm sorry, not 25. 25! Because I dropped the calculator. And we'll do the division. So 10 divided by 25.94 is 0.385505. Continues, and I'll write that number here, that's where it goes. So 0.3855055012. Okay, now, this math, here, to solve this, you cross multiply. So this times this, so 0.250L equals 0.3855055012. You divide both sides by 0.25. And we get L equals, hopefully the number is still in your calculator, which it is, so 0.25, 1.54202000, and so on, it continues. And this is liters. Okay, now, we gotta care about sig figs, and we gotta care about units. This has 3 sig figs, this has 4 sig figs, so our answer needs 3 sig figs, I'm sorry. So 1.54 liters. And again, right, it wants the answer, though, in milliliters. So now we've got to move the decimal place 3 places the other way. And we get this many milliliters as our answer. All right, on to the last type of problem. Okay. So this question is asking you to determine the number of grams. So we have our molarity equation. Molarity is moles over liters. We can put the molarity in there. It's 3.0. And we can put the liters in there, and we got to convert this. 1, 2, 3. So 0.080. And we got to solve for moles on top. So again, cross multiply. Moles equals this times this. So 3 times 0.08, and we get 0.24. Okay, now that's moles. We need grams. So we're going to take that 0.24, and if you remember in the moles to grams lessons, you multiply by the molar mass of lithium fluoride, which I can't remember, but it is 25.94, because we're using the same thing to make it easy. And I'm dividing in the calculator. 25.94. And we get 6.2256 grams. Sig figs. This has 3. This has 3. So 6.2, and this rounds that up. 3 grams is our final answer in terms of sig figs and everything else. Now you have to be careful. Sometimes they just might want moles, so you have to sort of look at what they're warning there. But I think that's it. That's all the problems on this sheet, and I'm done making videos until August. All right. Enjoy the rest of your summer, and enjoy the summer assignment.